So first of all, my name's David Weiss. Who is conning? Let's just go through that first. We are more than 300 insurance, investment, and risk professionals. Our client base is insurance companies. We're in 3 businesses, all serving insurers. We're in the investment management business. We manage over $100 billion worth of assets. We have a risk solutions business where we provide advice on how to understand and manage the risk. And we provide insurance research, which is a publishing business, publishing things of interest to insurance executives. We're located, headquartered in Hartford, Connecticut. We've been there since 1912 when the company was founded. At least at that point in time, it was considered the insurance capital of the world. Still got a very large insurance footprint, but we also have offices in New York, London, Hong Kong, and Cologne. Our risk solutions business, of which I'm a part, is really a commercial software business. We have a product we call Advise, which is a very large-scale, multi-period Monte Carlo simulation of an entire insurance company and the exogenous world in which it exists. That exogenous world is both models of natural catastrophes and other kinds of catastrophes like terrorism and the like, and an economic scenario generator, which is a global scenario generator that simulates macroeconomic variables and financial variables. And that feeds models of both the insurance business and the investment business, and a lot of things that flow from that in terms of accounting and tax and regulatory calculations. So it's a very, very large-scale Monte Carlo model. Our software consists of a model builder where our users specify the structure of the model, and then we actually determine an execution plan for how we actually build that into a runnable object. Then we simulate many, many scenarios on many, many computers. We end up having to transpose that data because the order in which it's simulated just tends not to be the order in which we have to analyze the results. And these models are big. The output of a single simulation is typically between a gigabyte at the very small side and a terabyte is towards the larger end, but sometimes beyond that. And in many instances, we have to do many, many different simulations. So it's sort of like a 3 or 4 dimensional cube of data, various properties that define the state of the world in an insurance company at a given period of time, and then different time steps and different scenarios of the Monte Carlo. So why Julia? Productivity and performance, standard kind of answers. It was really important for us. We designed a new architecture 3 years ago, and that new architecture really required both productivity and performance that no other language that we could find met our criteria. But also the combination of serving the scientific community and a general purpose programming language was very, very important to us as well. The team that builds the economic scenario generator, the global economic model, they're very much scientists, and their current mode of operation is prototype in MATLAB or Mathematica and then translate the code. And so we have an opportunity here to sort of circumvent and shortcut that cycle. What I wanted to say is, as a commercial software vendor, we have some needs that many of you may not have. One of those is commercial support, and so we're very supportive of Julia Computing, which provides that support to us. Stability of the language. I'm glad to hear that we're aiming for 1.0 this time next year, because that's going to become increasingly important. The quality is extremely important to us, the reliability. I think better, more thorough, more solid test suites need to be part of the whole process. Better documentation, not necessarily of the Julia language, but we also need a robust environment that has a lot of solid packages, like the AWS package, web servers and things like that, and we need that documentation to be solid across the board. Debugger is something that everybody in Julia Computing and many other people have heard us harp on. It's been the most important thing for us. And then we're very happy with what we saw with Juno. A really full IDE is going to be important as well. Also the ability to scale up. We're going to have hundreds of thousands of lines of code, and so that presents some challenges that maybe smaller scientific things don't necessarily have. Package management, static compilation, these things are going to be important. And also protecting our intellectual property. So our ability to obfuscate the code, and also eliminating GPL, which would, from a legal perspective, would have a hard time selling our software if we had that. Beyond those commercial needs, the other things that we want to see is that the language succeeds. Broad adoption, commercial adoption is going to be very important. The commercial success of Julia computing is going to be very important to us. Other things that are near and dear to my heart is the array, better arrays, think APL, reductions, ought to actually reduce dimensionality as opposed to what they do today, things like that. And then finally, multi-threading, multiprocessing, the ability to have a robust model for those, probably a Silk-like work stealing model. If Julia can really take a lead in exploiting massive parallelization and all those things, I think that would be the real additional catalyst that'll take Julia off like a rocket ship, and that would be good for everybody here, I think.
So let's thank our sponsor, Tony.
Hi, I'm Jeffrey Sarnoff, and I've got nothing to hype. I did want to take a few minutes to share some of my perspective on Julia. I spend time with Julia purely as a matter of choice. I was one of the ragged, jaded programmers who came across it very early. And as many of you have experienced, there's something quite good about not feeling bad about programming. One of the more remarkable things that I have seen is Julia's user group, that's us, is uniformly the most kind and protective of others online of any community I've seen. And I don't think that's just accident. There's this idea of self-selection and what Julia drives, and there is a symbiosis that tells us something about what we're all doing, what Julia is becoming, and why it's important to be able to make software well, cleanly, to more easily express one's concepts directly and have it all work. In my opinion, Julia is a lot better than we know yet. That what's to come with more users, with whatever it is that is to come, I believe that we'll all find the contribution that we have contributed to being substantial. Thank you for these moments.